Alright everyone, we're going to get started today by looking at some word problems for quadratics. And so we're going to be looking at some real world situations. You're always asking me when are we going to use this stuff, and so we're going to start to look at some of that today and actually see when we can apply these quadratics and solve things out to actually find some meaningful things. And so we're going to start. I'm going to show you this first problem all the way through, and it's going to be up to you to finish the rest of them. We're going to start by going through this first example, and then at the very end we're going to talk about some key words that you might see in these problems that can give you an idea of what way you need to go about solving them. So let's go ahead and get started with this first one. This first one we were dealing with Jason, who is jumping off of a cliff into the ocean, and we have that his height is given by this equation here. So we have h of t is equal to negative 16t squared plus 16t plus 480, okay? And so we are able to use that equation to help us model how high he is based on how long after he jumped. And so the first part A, is asking us how long after Jason jumped did he reach his maximum height. And so we can actually find that using what we've talked about with quadratics. And now this is talking about a maximum height. And I'm hoping that when you start to think about a maximum height, you're thinking about where is that point where that maximum is going to be. So if I think about a graph, this one has a negative a, so it's going to be pointing down. That maximum point is at the very top there, which we also called our vertex. And so what this question is really asking me is what time does my vertex occur? Okay, so when do I hit my vertex? And so in order to find that, we have to remember back to when we first started talking about quadratics, and it said that the time, or usually what we call our x value, but here it's our t, of that vertex is going to be negative b over 2a. It's an a there. All right, so I need to use that equation to find what my time is for my maximum height. So to do that, I need to identify my b. My b value here is a 16. So this here is equal to a negative 16 over positive 2 times a negative 16, because that is my a value. Okay, so I have 2 times negative 16 on the bottom and negative 16 on the top. So that's going to reduce down to negative 16 over negative 32. And so now my two negatives are going to cancel, so I'm going to end up getting a positive answer. I'm going to move down here just a little bit. And so I have 16 divided by 32. If I do that in my calculator, I'm going to get 0.5, or I want to keep it as a fraction here, so 1/5. Or sorry, 1/2. Let me get rid of that here. Sorry, 1/2 is what we really need there. Okay, so I know now that Jason reaches his maximum height after a half of a second. Okay, so it's pretty quick there, which makes sense because if you're jumping off of a cliff, you've got that initial push up, and then you're immediately pulled back down by gravity, and so you're not going to be at your highest point much after you actually push up. So for Jason, it's just half of a second. Okay, so that gives me my time of the maximum height. So that was part A. Now if we move to B, this one here is now asking us for the highest point that he reached, or that highest height. And so to find that, I need to remember back to that time I just had. So we had that the highest point occurred when t was equal to 1/2. Now if we remember back to when we found those the vertex, we found the y-coordinate, or what here is going to be our height, by plugging that value into our equation. So I'm going to take this 1/2 here, and I'm going to actually plug it back into my equation and solve it out that way. So I have negative 16 times 1/2 squared, so that's the 1/2 squared, plus 16 times 1/2, and then plus 480. All right, now I just need to use my calculator and simplify that down a little bit. I'm going to do this kind of a term at a time. So if I look at negative 16 times 1/2 over 1/2 squared, 1/2 squared is going to end up being 1/4. So negative 16 times 1/4 is negative 4, plus 16 times 1/2 gives me 8, and then my 480 is at the end. If I then simplify all of those together, I'm going to get that Jason's maximum height is 484 feet. So he was able to jump 4 extra feet above the cliff before he started to fall back down and actually go into the ocean. Okay, so this is 480 feet. Because we are working in real world scenarios now, we're going to get a lot of different measurements, but all of our heights on this worksheet in particular are dealing in feet. All of our time is going to be in seconds. So those are our units that we should be labeling these guys with. All right, so let's go ahead and look at our last part here, part C. So part C asks us when, or after how many seconds does Jason actually hit the water? And so to find that, we're actually trying to find when is Jason's height equal to 0. Okay, and that should start to set off a red flag. We want to know when is this equation actually equal to 0. And so what this is really asking us to do is to solve the equation. And so to solve the equation, it could be pretty difficult. We have various ways to do this, but some of them are going to be pretty hard. So I'm still looking at that equation, negative 16t squared plus 16t plus 480. Trying to factor that is going to be pretty difficult. Trying to graph it is not going to go very well either. And so the one that's always going to work for us and actually is going to work pretty much every time on this worksheet, actually every time on this worksheet when you do need to solve it, is going to be quadratic formula. And so I'm going to use the quadratic formula here and actually simplify this down. Now the numbers are going to get very big on me because we're using real numbers. They're not going to be the nice small numbers that we see in our math book anymore. We're going to start to get some real numbers that are going to be bigger and more complicated. And so don't get afraid, don't get scared off by those. Just use your calculator. It'll help you through these. So let's go ahead and get started here by setting up our quadratic formula. So I have t is equal to, and my first part is negative b, and my b value here is 16, so I have negative 16 plus or minus the square root of b squared, so here it's 16 squared minus 4 times a, which is negative 16, negative 16, and then multiply that last piece there by 480. Okay, so that whole thing is still under the square root. And then on the bottom I have 2 times a, which is 2 times negative 16. Alright, and if I go ahead and simplify this down, I'm going to go right below it here. I'm going to end up finding that I get negative 16 plus or minus the square root. If I combine everything under that square root there, I'm going to get 30,976. So I get 976, all divided by negative 32. All right, and if I simplify that down, I can do the square root of 30,976. Actually turns out to be a perfect square. It's going to be negative 16 plus or minus 176 divided by negative 32. Now, what I actually need to do here now is actually split these apart because I have those whole numbers. I want to look at 2 separate problems here. So what I have is negative 16 plus 176 divided by 32. Okay, and so I could do negative 16 plus 176 is going to give me 160. So this is going to be 160 divided by, sorry, it's a negative 32, which is going to equal a negative 5. We're going to talk about whether that's a possible answer for us here in just a second. But I want to do my other one. I would need to subtract the 176, so I have negative 16 minus 176, all divided by negative 32. And that's going to give us, let's see, that would be 176, or sorry, negative 16 minus 176, which is 192. So this is negative 192 divided by negative 32, which happens to equal a positive 6. So now what we actually want to do here is talk about whether these answers make sense. Because we have a real world problem, we have that possibility that our answer doesn't actually make sense for us. So these are times that we're working with. So if I have a time of negative 5 seconds, that means that 5 seconds before Jason jumped, he had hit the water. And so that's actually just the result of that parabolic shape. We get that parabola with a quadratic. That's before we're even really looking at our graph. So I actually want to get rid of that answer. I don't want to include that -5. But if I look at 6, that's the one that makes sense. 6 seconds after he jumps off of his 480-foot cliff, he ends up in the water. And so my correct answer here that I want to actually work with is the 6. And so when you do get done, you just want to check and make sure. Sometimes you will still get 2 answers that make sense. Sometimes just one of them is going to make sense. You just want to talk about it in that context. Does it really make sense to have either of these answers or both of the answers? All right, so like I said, that is the first example. That gets you an idea of how we're working through these. But I do want to some keywords that can help you decide what type of problem you have. And so the 3 keywords, or 3 phrases more than keywords that we're going to look at, are maximum and highest point when we're looking at hitting the ground or the water. So that's dealing with time. When did we hit the ground or the water? Or when we're at a specific height. So say 20 feet off the ground. When am I 20 feet off the ground? When am I 80 feet off the ground? Different things like that. And so when we're dealing with a maximum height, I'm hoping the thing you immediately think of is a vertex. Okay, that's always going to be our highest point. And so that one's going to be more like parts A and B that we use here. So you're going to find your time by doing -b divided by 2a. And then your height is going to come from plugging x in. So that pxi piece. You're going to plug x in and actually find that height after you find the time. If we're talking about when we hit the ground or the water, that's always dealing when our height is equal to 0. And so in that case, we're trying to actually solve our quadratic. So we're actually trying to solve this out. And so that's when our quad formula is going to come into play. Our quadratic formula. Our quad formula. That is when we're going to be using that quadratic formula. Now there is one other type of question that is on here that I didn't quite hit on, and that's when you're asking for the time of when the object or the person is at a specific height. And so that one, we actually need to look at when h is equal to some number. So h is equal to a number. And we're actually going to have to still use quadratic formula, but we have to set it equal to 0 first. So we're still solving, but we have to make sure that we have it equal to 0 before we use the quad formula. Okay, the quad formula, again, has to be set equal to 0 before we can use it. So we have to use that, but once we have it set equal to 0, plug in your numbers the same way as you have been on the other ones, and those will all work out. Okay, so those are kind of the keywords you're looking for. The other thing you just want to be careful of is some of them are going to ask you some sort of question at the end. So even once you find the math, you do still need to answer that last question of, will it make it high enough, or will you be able to do a certain thing? How long will it take, and that sort of a thing. Make sure you're answering all of those questions that the problems are actually asking you. Okay? Other than that, I think you're going to be really successful in these. Just make sure you're putting in a good effort, and these are all going to be due tomorrow. You have the rest of the class now to be working on these, and then we will look at them tomorrow as well as your homework from Friday. All right, I will see you on Tuesday.